Okay, today's lesson is 32. It's simplifying and evaluating expressions with integer and zero exponents. So let's go over the rule for zero exponent really quick. It's a simple kind of rule, but I don't feel like a lot of people understand what it really means. So I'm going to explain what it means after I show you the rule. Anything, and I really do mean anything, so I'm going to use a capital A for anything, to the 0 power is 1. It doesn't matter what it is. Now there is a matter of debate on whether 0 to the 0 power is 1, but that's a whole nother rabbit hole we're not going to go down. So, for example, if we had x to the third over x to the third, remembering our exponent rule of division, if you divide things with like bases, we subtract their exponents, right? So it ends up as x to the third minus 3 in the tops, because dividing things with like bases, we subtract their exponents. So it looks like x to the 0. And we remember that anything to the 0 power is 1. Now I'm going to explain what this really means. If I had 2 squared divided by 2 squared, that would be the same as 4 over 4, right? But over here, if I'd use my exponent rule, when I divide things with like bases, I subtract their exponents. I would have 2 to the 0, which, according to my rule, is 1. But if I look at what would have happened if I just simplified it, this would have been 4 over 4. 4 over 4 is also just 1. Okay? So that's all that rule really means, is that when you would actually simplify it, you would still get 1. So it's just a short way to recognize and write it down as just 1. So when you see something to the 0 power being multiplied, remember it's 1, not 0. That's the most common mistake I've seen, is that you guys will think it's 0 rather than 1. Okay, another just little side note, if I have anything to the 1 power, that's just itself, okay? So that's the same as 2 to the 1 power is just 2, okay? I feel like you guys already knew that, but I just want to remind you, because you'll start seeing them a little more now, and they're doing it to confuse you, so I don't want you to be confused. Okay, so anything to the 1 power is just itself. It's like multiplying by 1. We wouldn't say 1x, we just say x, because that multiplied by 1 is just implied. It's the same concept here. Alright, so now we have negative exponent rule. If we have a negative exponent, we want to try to make it positive. And in an effort to make it positive, I'm going to show you a rule that will allow us to do so. If I take a base that has a negative exponent, for example x to the negative 2, I can make it positive by just putting it on the other side of a fraction bar. So remember, this looks like x to the negative 2 over 1, so basically I just flip it. Is all I did. Okay? So now it becomes 1 over x squared. Alright, now this plays off of our division rule here. It just turns it to a minus. When you move things on the other side of the fraction bar, their exponents become opposite. Okay? So as another quick example, I'm going to show you this one. If I had, say, y to the negative 3 over x to the positive 2, if I want to make this y positive, I just move it down to the bottom and change its sign. So there's only a 1 left on top, and x squared, and then y to the third on bottom. And when I move this across my fraction bar, it becomes positive. And it works vice versa too. If I have something negative on bottom, for example, x to the negative 2 on bottom and y to the positive 3 on top, I can again simplify this one by moving it up top. So it would become x squared, just moved up top, y to the third. Now again, that's over 1, but I'm not writing that down because it's not necessarily useful to the context of the problem. Okay, questions? Alright, flip page then. We're going to start on examples. So these are all really quick. If you feel like I'm going too fast, or if you need me to slow down, you just say something and we'll get it answered. Okay? So if I have x to the negative 3, in order to make it positive, where do I move it? Down. Down, right? So it becomes 1 over x to the third, and that's it. On B, it gives me this problem. It says y to the negative 4th over x squared And I want to make the -4 positive, so I again move it down. So what's on left on top? 1. And I keep these in alphabetical order, okay? So don't mess that up. Make sure you keep them in alphabetical order. Alright, on C, it has 1 over w to the -4th. I want to make this positive, so I'm going to move it where? Up. I'm going to move it up. Now what happens to that 1? Nothing, really. It becomes 1 multiplied by w to the 4th. But 1 multiplied by anything is just itself, right? So I could have just put w to the 4th. Okay? Alright, any questions before I move on? That was example 1. Example 2 then. This is using that exponent rule that says anything to the 0 power is 1. So if I simplify this, it would look like a squared multiplied by 1. But what's a squared multiplied by 1? It's itself. It's an identity. So using the identitive property, I see that it's just a squared. Now then it throws you for another little side loop. It says, yes? Oh yeah, I'm about to go into that. Yeah. And then it throws another loop for it. It says a is equal to -2 and b is equal to -3. Now I could have plugged this -3 in for b, but it would have been a pointless step because it got rid of itself right here, right? So now all I'm doing is evaluating a to the -2, and I put that in parentheses. If I don't put it in parentheses, I'm in a little bit of trouble because I typed this into my calculator. If you want to try it, you can. Put -2 squared in there into your calculator. It'll look like this, -2 squared. And when you type it in, it'll be -4. But if you put it in parentheses, it gives you a +4 because -2 times -2 is +4. However, a negative multiplied by a 2 squared is 4, and then multiplied by a negative gives us -4. So there's a big difference between these two. Inside parentheses will give us a positive. Outside the parenthesis, it will definitely give us a negative. Okay, that works the same way if there's a parenthesis right there. Okay. All right. So no matter when you plug these in, you're going to get the same exact answer. If I plug this in back here and got -2 squared and -3 to the -3 to the 0, I still would have ended up with this being a 1. And -2 squared is 4. 4 times 1 is still 4. So it doesn't matter which route you go, you're going to get the same exact thing. These are interchangeable. Okay? So if you want to plug in 4, that's fine. If you don't want to plug in 4, that's, again, fine. Simplify before you plug in is my preferred method. It doesn't necessarily have to be yours. All right, here we have 3b to the -3 times b. And again, I can simplify before. It says if we multiply things with like bases, we do what to their exponents? Multiply things with like bases, we do what to their exponents? Somebody should be screaming, add then. Do we need to re-go over the exponent rules, guys? If we don't know them, we need to go over them. Do we need to go over them?
You add them.
I know that, but that's not my question. My question is, little side note here, let's go over some exponent rules. When multiplying things with like bases, for example, x and x, we need to add their exponents. So x to the 3rd times x to the 5th would be the same as x to the 3rd plus 5. I'm just simply adding their exponents. So I end up with x to the 8th. Okay, so if I had x to the -3 multiplied by just x, remember that this is an exponent of 1, right? Oops, sorry, that's a -3. This is just an exponent of 1. So it would be x to the -3 plus 1, which simplifies down to x to the -2. And combining this with the rule that we learned up here about moving negative exponents, I can make this a positive exponent by going 1 over x squared. Okay, any questions there? Okay, dividing things with like bases, again, just a reminder, when you divide things with like bases, you subtract their exponents. When you multiply things with like bases, you add their exponents. Okay, so here I have like bases, so I have b to the -3rd. I need to add the exponent, which is just 1, right? So I have -3 plus 1, which is -2. Now I need to make this b to the -3, or sorry, b to the -2 positive. How am I going to do that? Make it a fraction, move it down to the bottom, right? Now, the 3 stays up top. The 3 doesn't have a negative exponent. The b does. So I'm moving the b down below, which becomes b squared, right? So I'm done with that part. Now, it told us that b was negative 3, so I'm just going to plug it in. I have 3 over negative 3 squared. Again, I put it in parentheses to remind myself. So I have 3 on top. I have negative 3 times negative 3, which is 9, positive, right? And then I can reduce that. What does it reduce down to? What can it reduce by, should I say? 3, right? So divide both of them by 3, I get 1 up top. Divide the bottom one by 3, I get 3 on the bottom. Final answer, 1/3 positive. 1/3 positive. Any questions there before I move on? Okay. Now, again, I prefer to put them in before I simplify. And I know half of y'all guys are going, I'm just going to stab this into my calculator and move. There's a lot of calculator error that you can have here if you're not very careful with your parentheses. Okay? If you're not very, very careful with your parentheses, you're going to get every one of them wrong. And I don't want you to do that. Okay? Just to give you a general rule of how exponents, if they're like bases, for example, those two are like bases, and I'm dividing them, it would look like the top one, x to the third, minus the exponent of the bottom one, like that. So this would just be x to the 1, or x, right? As a general rule, your book will give you this, x to the m over x to the n. They're just using random variables to show you that the first one, to show you that the first one is just being subtracted from the second one. But I like this example a little bit better. So I'm going to give you a real number example real quick. If we have 3 to the 7th, sure, and 3 to the 4th, I can subtract those exponents because they're like bases, and I would get 3 to the 3rd. Okay. Now this works every single time, however you have to be very careful. Remember, we're subtracting these exponents. So if I had 3 to the 7th over 3 to the negative 3rd, I'm still subtracting them, but I have 3 to the 7th minus a negative 3, right? So this becomes 3 to the 7th plus 3, because negative and a negative make a positive. So it becomes 3 to the 10th, which is some huge number. I don't know what it is off the top of my head. We could type it in our calculator and find out, but that's not what's important. Is there any questions over this one? Is there any questions over this one? Final chance, guys. I'm about to do some examples. Okay. On A, then, it gives us x to the 7th shouldn't say that yet, over x to the 3rd. So because it's dividing things with like bases, I subtract the exponents. So I get x to the 7th minus 3, which gives me x to the 4th. So we're asking questions as we go. Say that again, I'm sorry. Very good. Okay. All right, on B, it gives us x to the 3rd over x to the negative 7. And again, we can still apply our rule, but what do I end up subtracting? I subtract 3 from what? What am I subtracting 3 from? Or sorry, what am I subtracting from 3? Negative 7, right. So I need to simplify that. It becomes plus 7, right? Negative and negative make a positive, same sign sum. So I have 3 plus 7, which makes x to the 10th. And that's all. Okay, next problem. This one gets, and these are the kind of problems you're going to see a lot, especially in Algebra 2. But you will start to see them here. And I know this one looks scary, but these are the easy ones, believe it or not. So we have x to the negative 5th, y to the 6th, and z. Then we have z to the negative 3, y squared, and x. Now before I deal with this, I say I'm going to put these in alphabetical order so that I can see them a lot better. Now the top one was in alphabetical order, so I'm just rewriting it really quickly. And as I copy these out of the book, I would do this. Remember that multiplication is commutative and associative. So this one's just backwards. So I'm going to put x up front, I'm going to put y in the middle, and I'm going to put z in the back. I just do that so they can see them directly on top of each other, and I'm not confused as to which one goes where. Okay. Now I can only deal with like bases here. It's a lot like terms. They have to have the same. This is basically the first name. Okay, they have to have the same first name. Like bases would be the same first name. So here I have x to the negative 5 and x. I want all of these to be positive. So in order to make them all positive, I would normally move the one furthest from 0. So here negative 5 is further from 0 than 1. Okay, so I'm going to move this guy down. So I have x's, this is x to the 1. If I move him down, it becomes minus a negative 5, which is plus 5, right? Or I just change my sign to a positive as I move it down. Now, out of 2 and 6, which one is further from 0? 6. So I want to move this guy up. So it becomes y to the 6 minus 2. Again, I just changed my sign. This was positive. It became negative. And on z, do I want to move the 1 or the negative 3? I want to move the negative 3 up because it is further from 0. So I get z to the 1, and I'm changing my sign, plus 3. Any questions before I move on? Somebody's got to have a question. All right. Take your word for it. So now all I'm doing is just combining the exponent parts. So I get y4, z4 over x to the 6, right? And that's it. I'm done. I say that's it, I'm done, like it's really easy, but do you feel like you could redo that again on your own? Okay. All right, these work the same way, and where we're going to see this the most with combining like bases here is in scientific notation. Okay, so we're going to see it a lot in scientific notation, but they're all base 10, so it'll be like 10 to the third, 10 to the negative 6, whatever. So the example 4 that they give us is dealing with things that are like scientific notation. It says the intensity of the sun can be measured in watts per square meter. The table below lists intensity levels for some common sounds. So here we go. Everybody should have this table on theirs. Okay. So these are kind of interesting. Rocket liftoff versus jet liftoff. There's quite a bit of a difference there. And then loud music, again, difference. Vacuum cleaner, regular speech, and then a soft whisper. So these are called watts per square meter, common types of sound. I don't know that a rocket liftoff is a common sound, but maybe in some worlds. So let's answer the question. It says, how many times more intense is the sound of a rocket liftoff, at 10 to the third, so we need to keep 10 to the third in mind, watts per square meter, than that of a regular speech at 10 to the negative 7th per square meter, and express this answer in exponential and standard form. Exponential is like scientific notation. It's in exponent form. And standard notation is with the number all written out. Okay? So I want you to think about what it is asking us to compare. Okay? It says that I want to compare this to that, but we need to remember which one this is and which one that is. So how many more times intense is the sound of rocket liftoff? So rocket liftoff to regular speech, right? To speech. So again, this is a ratio, right? Rocket to speech. So I'm going to put rocket over speech. So they told us what the measurements were. It's 10 to the third, 10 to the third over regular speech, which was 10 to the negative 7th. And this is in watts per square meter, so we need to remember that when we write our label down. I just need to simplify this fraction. What do I move? This negative 7 or the 3? I want to move the negative 7 up, right? So I'm going to move it up. So I have 10 to the 3. Move the negative 7 up, it changes the sign to plus. And I have 10 to the what? 10 to the what, guys? 10th, right? 10 to the 10th. So my first answer is 10 to the 10th. And I need to remember my label. It's watts per square meter. Okay. Then it said write it in standard notation. Now I can type that into my calculator, but here's the problem. Your calculator doesn't have that many pieces. When I multiply things by 10, what do I do with their zeros? I just keep adding them on, right? So when I say 10 to the 10th, how many zeros is my number going to have? 10, right? So it's going to start with a 1 and have 10 zeros. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I double check by adding in my commas. 3, 6, 9, 10. So my answer, this is thousands, this is millions, this is what? It's after million. Billion, and this is? Okay. So how many do we have? We have 10 billion, right? So 10 billion watts per meter squared. Don't forget your level. Any questions? All right, that's all I need then.